Hi, my name's Rebecca Donovan, and I'm from Centennial High School's National Math Honor Society. Today we're going to be talking about the basics of limits, including the definition of a limit, one- and two-sided limits, and cases when there's no limit. Let's begin. So let's start off with the definition of a limit. You would write it this way, and you say it as the limit of f of x as x approaches a is the limit. So let's begin with an example. Let's start off easy. So what about when f of x equals x? We know that the graph looks something like this. There are no holes in it. And so let's find the limit of, say, when x approaches 2. So we write this as the limit of our graph f of x as x approaches 2 equals, okay, and then we're going to look at where on the graph is what y value is the graph approaching as it goes toward 2. So this is our point 2 right here, and we can see from both sides that the graph approaches right here, 2. Okay, great. So then we know that the limit of f of x as x approaches 2 is going to be 2. Okay, let's move on to the next one. Okay, how about a more complicated graph? What about f of x equals x squared plus 2? So we know the x-intercept's right here. Then it's going to be about here and here, then here and here. So. Okay, great. So how about we find the limit at, let's do right here at 0. So this is 0 right here, and we'll write this out as the limit of f of x as x approaches 0 equals, and then let's see where it's approaching. So it's going down, closer and closer to 2 from both sides. So we can see it goes from here is like 6 down to 4.5, and then here it gets to 2. So it's decreasing down to 2. So we know that the limit for f of x as x approaches 0 is going to be 2. Okay, let's try another example. So this one's a little more complicated. This is going to have a hole in this, and we know that because, well, x minus 2 over x minus 2, that equals 1, right? Because these two cancel out. So we know it's going to be like this. However, if we plug in, let's say, f of 2 equals 2 minus 2 over 2 minus 2, we get 0 over 0. So that's going to be undefined. So then we know that it's not continuous all the way through. At x equals 2, there is going to be a hole. It's going to be undefined right here. So what does this mean for the limit? Let's find the limit when x equals 2. So the limit of f of x as x approaches 2. So let's look at this graphically. From the left side, we see that the value stays at 1 and it gets closer and closer to 1. At 2, it's undefined, but as it's approaching 2, it stays at 1. look from the other side. The other side is also approaching 1. So that's going to mean that as x approaches 2, the y value is going to approach 1. You might ask, well, there's a hole there. It's not at 1, at 2. But that's okay because the limit is defining what the y value is approaching as it equals that x value. It's not what the y value equals at that x value. So let's do one more example. Or let's move on to 1 and 2-sided limits. So this is going to help us figure out when we don't have a limit. So let's start by talking about left-hand limits. So with a left-hand limit, you're looking at the graph and you're seeing, let's look at one like this, you're going to see where it's coming from the left side. So what is that value approaching? And to indicate this on your notation, you're going to do a minus above your x value. So for example, I'll just write one out. It's going to look like, and let's say the x value that we're approaching is 3. Then you would do 3 from the left. And you would read that as the limit of f of x as x approaches 3 from the left equals the limit. Okay, now let's look at it from the right. So from the right, we go this way. And we see where it's heading to as it comes from the right at this intersection right here. So to indicate this, you're going to do a plus. So you'd write this out as, let's do 3 again, f of x approaches. So you're going to put that little plus sign there. So you would read this as the limit of f of x as x approaches 3 from the right equals the limit. Great, so let's move on to some examples. So the first one we have is right here. Okay, so let's draw this graph. So we know that y-intercept is right here, and it's going to look something like that. Okay, but then we can also tell from this equation that there's going to be a hole at x equals 1, because if you put in 1 for x, you're going to get 1 squared going to be 0 over 0, which means it's undefined. So at x equals 1, there is a hole. And then the second part of the equation here tells us that at x equals 1, f of x is going to equal 1. So we have a point there and a hole right there. So how do we write the limit for this? The left and right hand limits. So let's start from the left. The limit as x approaches, we're going to go 1 right here. Let's see what it looks like at that hole. As x approaches 1, to indicate from the left, we're going to do this minus, and then that is going to equal, let's look. So it's going up, and it's going closer and closer to 2 right there. Okay, so we know the limit for that is 2. Now let's look at our right-hand one. The limit of f of x as x approaches 1 from the right equals, let's look at this. Okay, we're getting closer and closer to 2 as well. So what does this mean? Both of the limits equal the same thing. And if both of the limits equal the right-hand limit and the left-hand limit equal the same thing, then you know that the two-sided limit as x approaches 1 equals 2. Cool. So now let's look at a case when they're not approaching the same thing. So let's find the left-hand limit first. The limit of f of x as x approaches, okay, at this jump here, it is approaching -1. And to indicate that it's coming from the left, I'm going to do that. So what does that equal? We're getting closer and closer to 2, right there. Okay, now let's find the right-hand one. The limit of f of x as x approaches -1 from the right is going to equal, let's see, so it gets closer and closer to this value of -2 right here. So we can tell that these are two different limits. So therefore, the limit of f of x as x approaches -1 does not exist. And this is because the limits are not equal. So now let's talk about some cases where there's no limit. So the first one is when left-hand and right-hand limits approach different values. We just talked about this one. So it can look like this. And you can see there's two different y values here. Okay, the next case is when the function oscillates indefinitely as x approaches a. So an example for this is f of x equals cosine pi over x, and it looks something like this, and it gets closer and closer and closer, and then bigger and bigger and bigger. And it just oscillates indefinitely. So there is no limit there. Okay, let's look at a few more. So another time when the limit does not exist is when the function approaches infinity or -infinity. So let's look at this one first. We can see that from both sides, the limit is approaching -infinity. So that means the limit does not exist. However, if you want to be specific, you can still say that the limit as x approaches 0 in this case equals -infinity. However, you have to know that the limit does not exist here because there is no definite value. For this one, they're not approaching the same thing at all. They're completely different. So here the limit is not going to exist. With this one, it is similar to the first one we were talking about. The limit is going to approach positive infinity as x approaches 0. However, the limit still does not exist because there's no definite value. And then our last one is just like the second one we were talking about, where they're going in different directions, so the limit does not exist. And just a reminder, in all these cases, the limit does not exist. But we can be more precise about why it does not exist with these explanations right here. Okay, so that's it for today's lesson. I'd just like to review real quick. Today we talked about the definition of a limit, one and two-sided limits, and cases when there's no limit. I hope this was helpful for you, and don't forget to do some practice. Thank you, bye!